Good day, everyone. I'd like to welcome you to Lab 1 Revisited, where Lab 1 is done right. Okay, so we have our Raspberry Pis, our elusive Raspberry Pis. They look a little bit like that. Now, this tutorial is going to assume that you have followed the tutorial I have posted previously, where you have used Etcher to flash a stock image of Raspbian Stretch to the Raspberry Pi. So it assumes that you have a clean Raspberry Pi installation. It will, however, work regardless. That being said, if you do have the time, I do recommend restoring Stretch. That way you can be 100% sure that you're at the exact same state that I am at. So what you will require for this tutorial is some sort of interface device, in which case this is a micro SD to USB, to actually get the micro SD card into your computer. If you have a laptop that has an SD card slot, you can also use a SD card to micro SD card adapter, which I believe was included in the package when the Pis were handed out. If you are having problems and you do need to borrow one of these or do not have access to one of these, please let me know. I'll lend you one. That being said, they're fairly cheap, and I do recommend that you at least always have one of these on hand, as your future career will basically demand that you are able to read all kinds of media. So, first step. At the end of the previous tutorial, we ended up with a Pi that had a fresh installation of Raspbian on it. We did not even plug the Pi in. We finished off at inserting the SD card. So that being said, we now need to remove the SD card. So flip it over until the SD card is visible. There is a little notch that you can use, and with your fingertip, gently remove the SD card, like so. So now you're going to want to put your SD card inside of your adapter. It's always good to look into the adapter and kind of see where the pins are facing, in which case mine is up. That way, when you insert it, you can make sure you're putting it in the right the first time, and you are making electrical contacts. So there we go, nicely inserted. So now I'm going to pop that into my computer. And it's going to come up in just a second. Or not. Sorry. So if it doesn't come up the first time, see, I did not go on the socket. I went slightly below it. Just take the card out and reapply. Don't force, you could break. It's not going in without force, you're doing it wrong. All right, plug that back in. All right, so very important. You're going to get a message saying you need to format the disk before you can use it. Cancel that. Do not format the disk. The reason you are getting that message is because the image on the USB stick contains multiple partitions. One of them is a FAT partition, which you can see here. The others are Linux partitions, which are not readable by Windows. Thus, Windows cannot explain them, and its first goal is to just tell you to wipe it by formatting. All right, so opening up your File Explorer and going to this PC, you should see a drive labeled boot. It's not necessarily going to be your E drive. However, it will be labeled boot, and it'll be approximately 43.1 megabytes. We will open boot. And while we're in the root, the first thing we're going to do is enable SSH. So by default, SSH is disabled on the Pi. The reason for that is strictly security. Since the Pi does come with the default username and password, so Pi and Raspberry, if it also had SSH enabled by default, which it previously did, Theoretically, anytime someone plugged a Pi in, if they didn't immediately change the password and it was exposed to the public internet, someone else could go and log in and have root permissions because they know the logins are Pi and the password's Raspberry. So yes, in the root of the directory, we're going to right click, go new, and we're going to go text document. We're going to make sure that everything's selected, including the extension. Now, if you cannot see the extension, go to view, options, view, and here you'll have a bunch of little things you can select. What we're looking for is hide extensions for known file types. So if this is selected, deselect it. All right, so back to rename. We're going to call that strictly SSH. Press enter. So this is a little bit of auto magic. The Raspberry Pi in its boot sequence checks this partition and it sees or it checks to see if the SSH file exists. If it does actually enable SSH within Linux. So that takes care of that. Now for the fun part, wireless configuration. So in the same directory, the root of that drive, we're going to create a new text document. This time, again, making sure to select the extension. We're going to call it WPA_supplicant.conf. Perfect. Okay. So this is where things are going to differ from the original lab. So first, we want to add our boilerplate, and you can find this in the document that's enclosed that I will upload. So first things first, we have our control interface, our country code, and then some miscellaneous boilerplate, update config in this case. Let me see if I can get a bigger font going on here for you. There we go. All right, so what we're going to want to do is basically set up 2 to 3 networks. So we're going to set up the class network, which is the Wi-Fi network. You'll notice there is some additional boilerplate here, so make sure that you do put that in, and make sure your spacing matches what I have here. Don't go adding any additional spacing, especially don't add spacing between the key and the value equal sign. All right, so here we have the SSID Wi-Fi. Obviously, for security reasons, in a YouTube video, I'm not going to go ahead and put the password there. 2 things to note. ID STR. So we do have a way to label within the system our wireless configuration. And priority equals 3. So I'll get into that in a moment. So that covers our class network. And you can notice here that we can leave comments by using the pound sign in front of something. Next, we're going to want to put in our AC secure network. So if Wi-Fi is not available, we are going to connect to AC Secure. AC Secure has quite a bit of different options. That's because Algonquin is using enterprise level security versus the residential level security that we're using on this network. And what I'd like you to note here are, obviously you're going to have to change that to your username and password. And here's the label I'm giving it. So AC Secure, and priority equals 2. Now, the priority is highest to descending. So the largest number is the highest priority. So it goes Wi-Fi first. Then if that doesn't exist, it'll fall back to AC Secure. And then finally, we're going to want to put our home network. So to do that, again, this is all uploaded for you. Basically, we're going to fill these in. I'm going to fill these in behind the scenes just so I don't divulge any kind of information. So just give me 1 second here. And you will notice that the priority on that was 3. So it is the last network that will be attempted. So first it'll look for Wi-Fi, then it'll look for AC Secure, then it'll finally look for that home network. All right, I'm saving the file and I'm closing it. So here we have our WPA supplicant file and we have our SSH file. So we will close down the directory, make sure those two text files are also closed, and correctly eject your USB. This might not be important for many things, but when it comes to an SSD card with various partitions, as well as an operating system that lives on it, it's worth the 2 seconds of extra effort. So I will eject that. And here I have the adapter with the SD card in it. Take the SD card out. Grab my trusty Raspberry Pi. All right, so here we have where the SD card goes in. The shiny metal connectors go up towards the Pi. So when you're looking at the SD card, what you should be seeing is the label. Make sure that's fully inserted. And now I'm going to plug that in. And I am strictly going to plug it in to the power. I'm not going to plug it into wireless, or sorry, not wireless. I'm not going to plug it into wired internet, a keyboard, a mouse, anything of that nature. All right, it's plugged in. We're going to wait a little bit. So remember, this is a little computer. It's not overly powerful. We want everything to be instant, but unfortunately, that's not how that works. Okay, so now my Pi has booted up. I've test pinged it behind the scenes, but now assuming again that you're doing this from home and there are no other devices that are named Raspberry Pi on the network, if I ping Raspberry Pi, it's going to come back with an IP. If you have IPv6 enabled on your network, it might come back with an extremely long IP that doesn't look like a normal IP. If that's the case, if you put the 4 flag on the ping, you will assure you get the IPv4 address, which is 192.168.1.156 in my situation. So now I have an IP address and I can move forward. So we've successfully set up network connectivity on a Raspberry Pi without a monitor or a keyboard. Next, we're going to want to set up localization in various services through raspi-config. To do this, first, we're going to SSH into the Raspberry Pi. I do have a tutorial out on the Windows Linux subsystem. Worth a watch. You can use PuTTY for the next step. I will be using the WSL terminal, however. In the WSL terminal, if you press Alt-Enter, or sorry, actually that's not a situation. Anyways, so first we're going to SSH into the Pi, and remember the default login is Pi at Raspberry Pi. So the Windows Linux subsystem differs sometimes from the Windows host system. As you can see, we're not getting the domain here. And I also have the wrong login, but that's an entirely different problem. So there's 2 things I can try. There is raspberrypi.local, but that's not going to work. So what I'm going to have to do is just use the IP address, but that's fine because we have that in the command window. So we'll just reopen the command window. Remember that's CMD, ping Raspberry Pi, the 4 flag. So it's 156. Back to the Linux terminal. SSH Pi at 192.168.1.156. We're going to get a authenticity of host. Yes. Our password and the default is Raspberry. All right, so now we're logged in. First thing we'd want to do, and we're going to read the message here. SSH is enabled and the default password for the Pi user has not been changed. This is a security risk. Please log in as Pi and type the password command, PASSWD, to set a new password. So we are going to do that. So it's going to ask us for our current password, which is Raspberry Pi. Sorry, Raspberry. Then we are going to put in our new password. Okay, so number 1, password change. So let's sudo raspi-config to get everything else set up. So we've already done the username and password. We don't have to worry about that. Next, we're going to go to network option. So do not enable or disable. Leave this as is for now. There is a student in the class who is actually having an issue due to this. I was not aware that this was an option in the configuration, but that explains it. So do not touch N3. All we want to touch here is N1. All right, so RFC mandates that a host name's label may contain only the ASCII letters A through Z, case insensitive, so case does not matter, the digits 0 through 9, and the hyphen. Host name labels cannot begin or end with a hyphen. No other symbols, punctuation characters, or blank spaces are permitted. So we are going to call this dreshay. Perfect. So we'll go to boot options just to see what we have. So here in the desktop CLI, by default, we have it set to console auto login, desktop auto login. And that's what spawns the graphical user interface automatically and logs you in automatically. You can change that to desktop, in which case it'll spawn the GUI, but it's not going to automatically log you in. So you're going to have to put your username and password in. Or you can actually not automatically start the GUI and you can spawn a console login or a console auto login. If you are not going to be connecting your Raspberry Pi to a monitor and you want to use the CLI for the majority of what you are going to be doing, or VNC for that matter, then it is actually preferable that you switch it to console, because if you have the desktop running bound to the HDMI connection that's not being used, it essentially is consuming memory and resources. That being said, if you want to play it safe, don't even worry about this. Cancel out. Don't touch anything. So wait for network at boot. If we change this and there's no network present, the Pi will actually fail to boot. Do not modify this. Choose a graphical splash screen. Would you like to show a splash screen at boot? Here you can basically have it show something a little bit more prettier than the 3 raspberries and a bunch of text flying by. I'm actually a fan of that, so I will leave it as is. Now, important to us, localization options. So first we're going to change the locale. Sorry about the text colors, but what we're looking for is ENUS. So once we find EN, then we'll look for ENUS. Once we find ENUS, we want EN_US dot UTF -8 UTF-8. And then we'll press the space bar on it, which will create a little asterisk in the select box. Then we'll press tab and it'll select OK. We'll press the space bar again. So for our default, we want EN_US dot UTF-8. Let it do its magic. So what it's doing right now is basically generating locales. There are a couple locales installed. I could have went through and deselected some and made sure that ENUS is the only one there. It would save a little bit of space, but not enough to be concerned. Okay, so that's finished. We'll go back to interfacing options. We'll go back to localization options and we'll change our time zone. So there's many time zones that you can select. Personally, I like going to the US, and then I just go to Eastern. You could also do GMT -5. There's quite a few. Back to localization options. Next, we're going to change keyboard layout. This is important because it does default to EN_UK, which will give you weird symbols where you think other things are supposed to be. So we will go with the generic 105 key Intel Intel key PC, international PC, the default. So here we have the ENUK selected by default. We're going to scroll to other. We're going to scroll, it's one down. So it's one down, you get ENUS. Then we can scroll up and we'll see English US. Enter, enter. So this will give you a key combo to get rid of X, which is the GUI. Generally, I do enable it. Perfect. Okay, so back to localization options. So we finished locale, we finished time zone, and we finished change the keyboard layout. We're gonna set the legal channel to be used, even though it's already basically in our WPA supplicant file, just to be on the safe side. Go to Canada. Perfect. So that's it for the locale. We're done with those options. Next, we're gonna go to interfacing options. So there are two things in particular that we do want to enable. We want SSH enabled, which it already is, but for sake of completion. And we want VNC enabled. Perfect. That's done with interfacing options. Overclocking options are actually disabled on the Raspberry Pi 3B. It cannot be overclocked at this time without some manual modification. I do not recommend it. It's already basically run at a very specific binning of that chip, hence the additional heat spreader. So overclocking these generally will lead to unstable results. If we go to advanced option, we have expand file system, ensures that all the data on the SD card is proper. We should actually go ahead and run this. Perfect. Go back to advanced options. Overscan is to accommodate certain televisions. So if you see the image is too zoomed in, you can mess with the overscan. Memory split. So we're not using graphics very much in this course. By default, the GUI is given 64 megs of memory. Keep in mind there's only 1 gig. So you can actually go ahead and change that to 16 if you do not plan on using the GUI and are planning on using mostly console. You do still get the benefit of the GUI. You'll just kind of be a little bit more limited as to what you can do. Audio options. So you can force audio auto, which basically it'll sense detect where if a headphone or if headphones are plugged into the jack, audio will be routed through those. If not, it'll try to send them via the HDMI, or you can specifically force it to do one or the other. Resolution. Essentially, this is fairly straightforward. I'm going to set mine to 1920 by 1080. So this is the resolution of the display. Pixel doubling? No. And GL driver. So this is basically the graphical video driver for the X server. So for acceleration, things like watching movies. The default's fine. Do not touch this. If you're interested, do a Google search, but generally you would not change these settings unless you were trying to accomplish some more advanced emulation. All right, before we go to update, we're going to reboot. Perfect. So the Pi is now in a reboot cycle. I'm going to ping the Pi. When you're pinging from a Linux Linux shell, essentially you don't have to give a flag for it to keep going. The default is keep going. The reason I'm pinging it is because I will start getting responses when the Pi comes back up. So now I know it's back up. Now I'll SSH back into the Pi. So that was Pi at 192.168.1.156. And of course, I changed the password from the default, so it is now the new password. And we will sudo raspi-config one more time. Now we're going to go to update. and let it do its thing. So the update feature in raspi-config is the same as running sudo apt minus get space update. And that's what it's doing right now. It's pulling in the package repositories, checking to see if there are, in fact, any updates. So as you can see, the raspi-config is actually a package that can be upgraded. And there it goes. Oh, actually, you know what? I was wrong. That's specifically for updating raspi-config. It does not upgrade the system. So now raspi-config is finished updating. We go back into it. Doesn't look like anything's changed. So we are good with raspi-config. I type in ifconfig. There's my WLAN 0. Let's move on. Back to the document. So we have gotten network connectivity on a Raspberry Pi without a monitor or a keyboard. We've set up localization in various services through raspi-config. And now we're going to do the initial operating system updates, which is our final step. So like I was mentioning before, you can use sudo apt-get, but let's not do that. Apt-get's been around for a while. There is a new version of apt-get that's basically the same. It just looks a little better and it gives you more progress indicators. So we'll go sudo apt rather than apt-get update. As you can see, I get a little bit of color going on at the bottom occasionally, and it's a little bit more clear as to what it's doing. And it reminds me that I can actually check a list. So if I run this command here, it'll tell me everything that can be upgraded, and that is quite a bit. So these are the packages that essentially can be upgraded. It's really not that much, but it's enough. So now I can go sudo apt upgrade. It's going to prompt me if, there we go. So 57.3 megabytes of archives, an additional 2.99 kilobyte of disk space will be freed. So we'll actually gain space in this update, not lose it, and we will click yes. So because I'm on the most recent image and because Stretch isn't that long-lived, I don't have a tremendous amount of updates coming. So realistically, if you did want to do this at school, that's fine. Even if multiple people were to do this at once, assuming that you did, of course, flash your SD card. Wait for that to finish. All right, so what it did there was it just downloaded the updates. Now the progress that we're seeing is it updating. So it actually unextracting, installing, configuring, modifying, etc., etc. You'll notice that the downloading goes super fast and the progress of updating takes a little bit longer. That's because the network on the Pi is faster than, let's say, doing computational stuff on the Pi. Let it run. Generally, I like to read what's being updated while it's updating because it gives me an idea of what to check for new features or change logs to go read. So for example, we can see here VLC has had some updates. Samba, which is Windows file sharing. Nothing else that's super exciting. OpenSSL has had an update. Generally, that's a security fix of some sort. Even on a slower internet connection, this really won't take that long. The overall download was fairly small, and it's more of this that's consuming the time. All right. Perfect. Okay, so we're done with the update. Now there's one, or upgrade, I should say. There's one final upgrade. So sudo apt dist minus upgrade. So that's distribution upgrade. That's going to upgrade more important stuff like the kernel. And thankfully, we have no updates to do on that end. Now, we are ready to reboot again. There is one more thing I'd like to do. So sudo RPI upgrade. Oops. Or RPI update, yes. What this is going to do is actually get a new firmware for the Pi, assuming that there is a new firmware available, and flash the Pi's EEPROM or whatever memory it has to said new firmware. This also does not take very long. So as you can see, this bumps the Pi to the this bumps the Raspberry Pi to the 4.14 Linux kernel. 4.18 is what's currently being included if you were to get Ubuntu 18.10, and then 4.20 is the most recent version, and that's essentially that was released on Christmas. Okay, so to reboot or to activate the newest firmware, you need to reboot. So we will do one final reboot just to make sure everything goes good. I'm going to actually go ahead and do a halt because I want to unplug the power and plug the power back in just to be 100% sure. All right, so that's unplugged. And let's plug her back in. Okay, so start pinging that address. Oh, we were SSHing, but as you can see, it's letting us in. So it is up. And there we go. We have Wi-Fi. We have SSH. We theoretically have VNC, even though I'm not going to test it. I'm fairly sure it'll be working. We are updated. We have the newest firmware, and everything works great. So that concludes lab 1.3, I suppose. I do apologize if there was any confusion. Hopefully this clears everything up. Hope everybody has a good day. Just one more note. If we do want to reach our Pi now from the host operating system, previously we had pinged the Raspberry Pi. That still works because it's cached. If I flush the DNS and I try to go ping it, still worked because it's actually cached on the router now. But if I ping driche, which is my new host name, I also am going to get that response. And let's see if that also works in the Linux terminal. It does. So you'll see here, driche.irony.local, which is my local network. Everything copacetic.